So now that we know more about how electricity works, what components can we use? And how do they work? We mentioned before the diode, and the symbol for this element looks like this. And before we proceed with showing every component, let's learn about how electronic diagrams work so you can start designing circuits and reading them. We represent them in a 2D view where symbols represent components and we can connect them with lines representing the wires. Now, this is a battery symbol. Just like a real battery, it has two terminals, one for positive and one for negative. Then, this is the symbol for a resistor, which also has two terminals. Although resistors don't have polarity, so it doesn't matter which one is positive or negative. Connecting them like this would represent the following circuit. But not all components have two terminals. Some others have more, and some of them have polarity, and some others don't. So here are some popular components. You can see its symbol and a picture of how it looks physically. There are many more with different variations. Let's start with the diode, and from it we have the Zener diode, and then the LED, which stands for light emitting diode. The diode allows flow in one direction, but when you have current flowing in the opposite direction, then it doesn't allow it. This is commonly used for protection. When in normal operation, it allows current exiting one component, but if for some circumstance you have reverse voltage from either the user plugging the battery the other way or malfunction of another component, then you prevent damage. Now we have a small variation called the Zener diode, which works about in the same way, but it allows flow of current in the opposite direction after certain voltage. Then we have the LED, that while current is flowing through it, it emits light. There are many more, but those are quite popular. Then we have resistors. This just simply causes a resistance in the flow. Many times we power the same component with the same voltage source, and it's very likely that some of them can't withstand the amount of power for prolonged times. That is why we add resistors, so those components don't overheat or get damaged by the voltage. Also, electricity flows through the path of less resistance. Sometimes we add this resistance strategically to elaborate some sort of logic, as I'll show you soon. Then we have the transistor. This is a component that revolutionized our society. Computers and most digital devices are made mostly of transistors, and its basic functionality is like this. We have two types, PNP and NPN. They are named that way because actually transistors are made of two diodes, connected like this. And we can connect them in two ways, positive, negative, positive, or negative, positive, negative. Transistors have three terminals, base, collector, and emitter. Basically, when a current is applied to the base, the transistor allows flow of current from collector to emitter, or from emitter to collector, depending on the transistor. Both PNP and NPN are very similar. The difference is that PNP needs a positive current on the base to allow the flow, and the NPN needs a negative current on base. This functionality allows the transistor to act like a mechanical switch, but with the difference of being safer and way smaller, and we can make the switch go on and off way faster than a mechanical switch. It can also act as an amplifier where you have a weak signal like heart pulses connected to the base that allows a bigger current to travel, actuating something bigger. Similarly, we have relays. They're like transistors but mechanical. With a low power current, it magnetizes a coil in the inside, then the relay allows the flow of another current to pass. This can have a higher voltage passing through without making any connection with the control circuit. This is often used as protection, just in case something goes wrong with circuit B powered by high currents, so it doesn't allow damage on circuit A working with low voltages usually designed for control. Another very common that has different shapes is the potentiometer. This is a variable resistor in the form of knobs, slides, or many other different shapes. They are widely used for increasing or decreasing the amount of flow in a controlled manner, either to increase or decrease the volume of a speaker, or to dim lights, or even as position feedback, where you can calculate the position depending on the resistance level. Another often seen is the capacitor. This one is very similar to a battery. It stores electricity like a battery as soon as it gets power and releases it when electricity is not coming in. This is also a great protection against sudden spikes or changes in voltages. Have you wondered why many components slowly turn off even when you unplug them from the outlet? It's because the capacitors are releasing the energy stored slowly. Many circuits can get damaged when power is suddenly cut off. Here, the capacitor allows the cutoff to be fading slowly instead of sudden. Also, capacitors are used to stabilize voltage levels, where they are a bit unstable to make them a little bit more linear, perfect for filtering signals and some other advanced stuff that we don't need to worry about. Then, some interesting variations from these components that we already mentioned are the photoresistor and the phototransistor. The photo prefix means light, and as you might have guessed, they work with light. Photoresistors vary their resistance level depending on the light detected. This can be useful in streetlights, detecting less light as the night comes in, decreasing the resistance and allowing more power to flow and power the lights. Also, the phototransistor, which allows or blocks the flow of current when light is present. Also, push buttons and switches are often used, and both are very similar. The difference is that switches stay on or off, and push buttons only change while you're pressing them. Finally, we have integrated circuits. Most often, there are circuits that already do what you're trying to do, and instead of using these basic components with transistors or resistors, you can just have them packed in a small chip. They go from basic applications like timers or counters to more complex things like microcontrollers or computers, which is where we will focus on in the next module. But for now, these are some basic components, and there are many others that can be easily found with some quick research on the internet. There are different variations that can be triggered with some other sources like static electricity or magnetism. Then, adding to more integrated circuits, you can have sensors that detect moisture or oxygen levels. This little list was intended to show you how electricity works and how it can be manipulated. But to start designing complicated circuits, you don't really need to use them a lot, because with microcontrollers, we can design any logic that we want, modify it, improve it, and just add sensors and actuators in a very easy manner so even beginners can start creating useful prototypes from scratch.